and welcome to another Climate Emergency Forum. Before we get started, I'm going to ask you to smash that like button. It helps us with the YouTube algorithm. All right, so the more you like the videos, the more other people will get to see it. And if there's something that occurs to you while we're speaking and you think that we're not covering something enough, please go ahead and put it in the comments. And maybe something we'll talk about in the future. We appreciate your feedback. But without further ado, our topic for today is ocean cycles, El Nino and La Nina. And I'm going to guess if, like me, you've been hearing a lot about El Nino. And what the heck is El Nino anyway? First of all, I'm sure you know that this is a Spanish word, and El Nino means the boy, and La Nina means the girl. And really, these are just words. These are words that denote a natural phenomenon that happens. What we're talking about with La Nina and El Nino is a different phenomenon that occurs naturally in the climate cycle. So these are basically periodic variations in wind and sea surface temperatures. And hopefully Paul is going to get into the science with you a little bit later on in the show. But if you're like me, it's confusing. How do I remember this? How does it affect me? How can I keep the two of them together? Well, do you remember that book, Men Are From Mars, Women Are From Venus? Because I do. It was a self-help book quite a few years ago, trying to help people stay in their relationship. Well, Mars is the red planet, and red denotes warm. So when you think of El Nino, think about where men are from. Mars, it's red, it's on fire. That means warm. Well, Venus is rather cool by comparison. It's got yellow coloration and white coloration. La Nina, the female denotation of the phenomenon, not in the actual sense, is cooler. And La Nina as such is also cooler. These two forces, if you will, go back and forth. It's the swinging of a pendulum. So if you think about it that way, it's really not so hard. Think about it when you're in a room and it gets too warm, you want to turn on the AC, hopefully not too often. Maybe you turn on a ceiling fan to cool. So that again is a turning from one to the other. When it's too hot, you want to move towards cold, and then it gets too cold and then you turn the air off. So those are how they're described. And they basically go back and forth depending upon the currents of the trade winds and the upwelling of the water. So we're thinking of the warm water on the north and southern part of the coast of North and South America and the Pacific Ocean. And the opposite is the same with La Nina. And each of them create their own weather patterns: hot weather, cooler weather, rainy weather, drought. And with climate change, these are getting more extreme. And I'm hoping, Paul, that you can take it from there and explain it to us in much more detail.
Yes, thank you, Regina. So the term ENSO, E-N-S-O, stands for El Nino Southern Oscillation. So the El Nino part is really an atmospheric phenomena, and the Southern Oscillation is the response of the ocean. But basically, this is an ocean-driven event, I think is most likely. The ocean triggers it. We don't know for sure. It's a quasi-periodic cycle. Quasi because it's not, there's a lot of variability in the period. So we're talking about for anywhere from 2 to 7 years. Generally, after there's a strong El Nino, then there will be a La Nina, and then another El Nino. It normally cycles back and forth, but not always. It seems that under abrupt climate change, with the greatly warming oceans and stratification of the oceans, that the behavior of the El Nino Southern Oscillation, or the ENSO pattern, is becoming a bit more erratic. Basically, what happens is warm water on the western equatorial Pacific pools, and that warm water creates a lot of water vapor in the air and a lot of convection, and the air rises over the West Pacific at the equator. And then that air that rises spreads to the east at elevation, cools down and descends over just off of the coast of South America. It descends down and then to complete the cycle, the winds then head to the west along the surface, and we call those trade winds quite often. So those winds, when we have the warm ocean on the western Pacific, equatorial Pacific, we'll get cool water off South America because the water is pushed away from the continent and there's upwelling, and that upwelling water is colder. So that generally happens. That cycle is called Walker circulation. Now, what happens when enough water, warm water, builds up in the western equatorial Pacific? Once it's triggered, and we're not exactly sure of the trigger, maybe it's just the huge, vast amount of warm water, not just at the surface of the ocean, giving high sea surface temperature, but over, to great depth as well. That warm water eventually builds up enough, and then it sloshes eastward across the Pacific until it makes it all the way to the coast of South America, bringing very, very warm surface water and water at depth. Then what happens is you don't get that. The Walker circulation greatly slows down because you don't have all that convective uplift on the western Pacific. So that means that because the Walker circulation slows down, the trade winds really, really slow down, and they're no longer pushing that warm water to the west. So it can come right across the equatorial Pacific and pile up off South America. And that's the very powerful El Nino phase. Then when the system reestablishes itself after the heat is released from the ocean to the atmosphere, that's the biggest thing. So we set global temperature records in the atmosphere when there's very powerful El Ninos, because the global average temperature in the atmosphere can be 0.3, 0.4 degrees warmer than it would be without the El Nino. Then, so after that energy is released from the ocean, then the cycle repeats. The warm water starts building up again in the West Pacific. We can sometimes go to just a neutral state and not have the La Nina appear at all. But generally, the La Nina does appear, and then the equatorial Pacific to South America is very cold. So obviously, this affects where heat is released and absorbed on the surface of the planet. We know over 93% of heat is absorbed into the oceans. And like I said, the ocean surface warming, and we know that the ocean currents are also changing. I talked about the AMOC, the Atlantic Marindal Overturning Circulation Pattern. So the ocean currents are changing, the oceans are warming, they're becoming more stratified. And these things seem to be having an effect on this cycle. And some people think we might head into a perpetual El Nino-like state. But what is interesting is the last several years, we've had a very powerful La Nina. Okay, so if you go on Earth Null School and just look at the sea surface temperature anomaly in the Pacific Ocean, you see very cold water extending all the way to South America. So this is ongoing. It's been several years now that we've had this state, which is very unusual. It could set a record length. So, there's a lot of interesting research that needs to be done to connect this more, to figure out the details and how it relates to the abrupt climate system change. But it definitely has global effects on rainfall, heat, and drought around the planet. So for example, if you're in California and there's a strong El Nino, you generally get very, very heavy rains and landslides, mudslides on the west coast of California. If you're on the East Coast and there's a La Nina, you get more hurricanes. So you need to look at the global maps of where you are to see the effects on your location. But in general, the El Ninos are about up to 0.3 degrees warmer than normal, and the La Ninas can be the opposite, cooler than normal. And that's on top of the climate change warming.
Thank you for helping us understand that a bit more.